Alright, in this video our goal is to prove trig identities. Now proving trig identities is similar to what we've done in algebra or geometry in proving algebraic identities and stuff like that. So we'll start with some review by proving an algebraic identity, and our goal is to start with one side and make it look like the other. So here I'm going to start with this left side because it looks a lot more complicated. So right now I have x squared minus 1 over x minus 1 minus x squared minus 1 over x plus 1. Oops. 1. And I want this to get this to equal 2. So I can start by getting a common denominator, or by factoring actually. So x squared minus 1, I know factors to x plus 1, x minus 1 from difference of perfect squares. Now, there are multiple ways you can go about doing this. This is not the only way you can prove it. So first, I can see I can cancel these out, I can cancel these out, and I'm left with x plus 1 minus x minus 1. Distribute that negative. X plus 1 minus x minus, or plus 1. My x's cancel, and I'm left with 2. Which equals the 2 that I was starting with. Okay, so I started with this side. I thought it was more complicated and I wanted to simplify it down to look like this. You always want to keep in mind kind of where you're going, and you want to make sure the steps you're taking are steps that might actually get you to where you need to go. This works similarly for our trigonometric proofs, and there's some general strategies that can help you to do this. Now, this looks like a lot, but it's not too bad. Basic ideas for your proof: you want to begin with the expression on one side of the identity, and you want to end with the expression on the other side. So you're always working on one side. You do not want to go on both sides. The proof in the middle is showing a sequence of expressions, each one easily seen to be equivalent to the preceding expression. So you don't want to skip steps. You want to write out all of your steps to make it clear what you're doing and how it's simplifying or changing to look like what you need. It might be a good idea to begin with the more complicated expression and work toward the less complicated expression. It makes things a little easier. If no other move suggests itself, convert the entire expression that you have into sines and cosines. Generally, you can see a lot from sines and cosines because you can get your tangent, your cotangent, you can get your secant, cosecant. It's easy to see from sine and cosine. You always want to combine your fractions with a common denominator because you're trying to simplify. Simplify is generally condensing. When you're looking at your Pythagorean identities, this is going to be very, very useful. The sum of squares. And this should be the difference of squares, but may be useful in dealing with our Pythagorean identities. So now, let's look at a trig proof here. So we want to work only on one side to make it look like the other side. In this problem, neither one is more complicated than the other side, so you can actually pick which side you want to start on. I'm going to choose to work on the right side. So I'm going to draw a line right down here. So I always work on the right side for this problem. So I can multiply both sides, top and bottom, by secant of x plus 1 or secant of x plus 1. So here I'm just multiplying. I'm not changing anything, I'm multiplying by 1. So in the numerator I have tangent of x and secant of x plus 1. And then here I have the identity I could use before, where it becomes secant squared x minus 1. Okay? So this is difference of perfect squares. Now from here, we know that secant squared x minus 1 is the same as tangent of squared x. So I have tangent x secant x plus 1 all over tangent squared x. And this I can simplify, and I have secant of x plus 1 all over tangent of x. which is what I was looking for. It's my left side. So I decided to look for the bottom because I knew I wanted to get a tangent of x on the bottom. And I knew my Pythagorean identities, if I can get secant squared x minus 1, I can get tangent squared x. And then from there it could simplify. Alright? So you can also work on the other side. It's going to be a similar process. You multiply top and bottom by secant x minus 1. And then you'll have your tangent squared x on top instead of the bottom. It'll basically be this side flipped. So let's try another one. This one looks a little bit more complicated. So you have sine to the 5th x cosine squared x equals cosine squared x minus 2 cosine 4th x plus cosine of the 6th x all times sine x. So right off the bat, this side looks a lot more complicated. So I'm going to work on the right side again. So these all have a cosine squared x in common, so I'll pull out a cosine squared x. So I know I kind of want that in the end. So then I'll be left with 1 minus 2 cosine squared x plus cosine to the 4th x all times sine of x. And so here, this I can factor. So I'll be left with cosine squared x. I can bring my sine x over, sine x. This I can factor. I have 1 minus cosine squared x, 1 minus cosine squared x. And then from here, I know that 1 minus cosine squared x using our Pythagorean identity is the same as sine squared x. So I have cosine squared x sine x times this is sine squared x. And then this is sine squared x. And then I can multiply these together. I'll have cosine squared x. Here I can add my exponents. I'll have sine to the 5th x. And then from here, I can just flip them. And I'll have over here what I was looking for. Now going from this side would be a lot more complicated and require a lot more thinking and guesswork, so it's always easier to look at the less complicated side and then go to the more complicated side. So I have 2 more that I want you guys to try. So you can take these, remember, look at the more complicated side. So for this one, you might want to start looking at this side. You'll use your quotient identities. You might use your Pythagorean identities. So be sure to look at that. You want to combine fractions, things like that. This side might be one or the other. You can work on either side. It might help to work more on this side. But that's just personal preference. I can see it working on either side. So try those. I'll check them when you come into class tomorrow.